Okay, so we're gonna start at 12:05, but until then, I'm just gonna review the general process of this. So each team will have 4 minutes to present their presentation, and immediately after that, we will go straight into the Q&A, which is also gonna be 4 minutes. So the total time for each team is gonna be 8 minutes. After that, you're done. Yeah, so we're still waiting, but we will start at 12:05.
All right, are we good to start presenting?
Yes. Judges, are you all ready?
Yes.
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 Okay, great. And then I'm gonna start a timer at 4 minutes, and I'll start it now. So go ahead.
Hi, everyone. I'm Lindsay,
I'm Janud. I'm Darcy. And I'm Jacob.
and we're here to tell you about our project, CAM. If our slideshow would work. There we go. First off, everyone, I would like you all to meet my sister, Kylie. She's 19. She just graduated from high school. She absolutely loves to sing and dance, and she has Down syndrome. As part of a transition program in my hometown, Kylie and her peers work 2 to 4 hours a day every weekday, but because of their disabilities, they don't receive any compensation, and they are far from alone. 37 states in the US allow employers to pay adults with disabilities a sub-minimum wage. The result is that 60,000 disabled workers like Kylie make $3.50 an hour or less. I know I don't have to tell you all that in today's economy, $3.50 an hour is next to nothing. Of all the Down syndrome adults in a 2018 study, though 57%, the majority, had jobs, almost 28% were looking for but could not find jobs. Our project, CAM, attempts to address these unsettling statistics, incentivizing employers to pay disabled adults a fair wage. Wearing a camera, employers walk through the tasks that their workers will learn, perhaps clearing trash from cafeteria tables between lunch periods, a job Kylie's actually done. As they demonstrate, CAM records and analyzes the process to be able to train disabled workers, thus reducing the training overhead of the employer. After training, the worker can wear a cam to assist them with quality checking. This includes a wearable feedback device, a bracelet that gives vibration cues for a job well done, like clearing all the tables, or cues for a possible mistake, like missing a piece of trash.
So now we'll give you a demonstration of CAM.
This is Cam. I'm wearing a camera. This bracelet gives me feedback. Let's check my results.
By pressing the button, she is able to ask for feedback on.
But it should give me 2 buzzes to indicate that the table is dirty.
There's still more to clean.
1 buzz, 2 buzz. Now let's clean it. Now let's check my work again.
The table is clean.
I got 1 buzz. That means the table is clean. Thank you.
To make CAM, we relied on Google's Cloud Video Intelligence API. To incorporate hardware, we interfaced our Python program with an Arduino to create a bracelet that allows the user to initiate feedback. The bracelet also vibrates to cue the wearer and includes a modulator to adjust the vibration. Finally, we use TK and text-to-speech libraries to implement a dynamic UI to give the user feedback both visually and audibly, which you heard in the demo. During this project, we had our share of challenges. Google's API is geared towards analyzing stored video, so we had to adapt it to simulate live video processing. This is why you saw a slight delay in the demonstration. We also had to calibrate this AI, which merely recognizes objects, to translate information into the context of our task, in this case, whether the table is clean or dirty. Finally, we had to connect this software component to the hardware, making sure that the bracelet device could initiate a check and that the program could respond by triggering a signal to the bracelet. So that's CAM. Thank you all for listening.
Do you guys have any questions for us?
What is the accuracy of the video recording that you are trying to send it to the Google API? I mean, how accurately it try to detect the objects on whatever they are?
Sorry, go ahead.
No, I'm good. That's it.
Yeah, it depends very much on the situation. If the image that it's processing is a lot closer up, so if it can see the whole tabletop, it's a lot more accurate. From a distance, it's sometimes a little bit less accurate, but we were working on ways to kind of improve the granularity of that. But in general, as long as there are reasonably recognizable objects on the tabletop or in the space, it'll pick that up and provide the appropriate feedback.
Okay. And I could hear that you said the video need to be downloaded somewhere, and then that's where the Google API is trying to read it and get the response back.
What the Google API expects is like a video file that you either upload or have uploaded and a link to the API. So we sort of take the live feed from the camera and we cut it up into a very small chunk at the moment that you presses the button, and then we send that.
Okay. So what is the archival mechanism for that? I mean, how huge you can store those videos for a day, right? I mean,
yeah, we just store like a few moments of the video for a very temporary time. After the image or the short video has been sent to the API, it's discarded. We don't save that at all. We just get the response from the analysis of that clip.
Everything's
So what is the response time?
On average, we observed that the response time, the API took about 5 or 6 seconds to process the videos that we sent it. Of course, for a real implementation of this, we would want to speed that up a great bit. But for the demo, we found that it was around 5 seconds.
Cool. So what is the disaster mechanism that you are planning if you are not receiving any response back from the API?
We had a few catch mechanisms in there if we didn't get a good response from the API, but really our system doesn't have a great response to a failed API call. So we could certainly add that in the future, and that would be something to make the program more robust.
Okay, cool. So one last question. What is CAM? Any abbreviation for that?
CAM is partially based on the fact that you're wearing a camera, but my sister Kylie's initials are KMA, so just reorder that to KAM.
Okay, perfect. Thank you. It's a really great innovative idea. Congratulations, everyone.
Thank you.
Hi, this is Mustafa. I do have a set of questions. First of all, I think from the social impact perspective, real powerful project. I had a question more regarding there is a something called American Disability Act (ADA). By any chance, does the American Disability Act consider the fair wage mechanism for the people with the Down syndrome or this kind of disability, or it doesn't cover that?
So, when a disability is mentally impairing in the way that Down syndrome is, because even high functioning adults with Down syndrome, like my sister Kylie, will never have a mental age above 13 or 15. That is classified differently than something like ADA, which is not as much of a developmental mental disability as Down syndrome is. So legally, disabilities like Down syndrome are called 43C, which is where how we were talking about those 37 states. Disabilities under 43C are you can pay those people as little as 25 cents an hour. And of all the adults working full-time jobs, the average 43C adult who is working is making just $7.80 an hour, which is barely above federal minimum wage.
Okay. Thank you for that information. The second question I have is the demonstration of this device, right? There will be different set of training videos per job. So the demonstration, this particular device you mentioned, it's about the cleaning. The table is clean or not. So the ideally, you will train each and every job and determine that, what is the success criteria for that particular job. Is that understanding right?
Yeah, so we do want to, in the future, work on this and improve it to do multiple jobs. We actually started gathering training data for reshelving books in a library. And basically, what the AI is doing is it is identifying objects within a set, and it knows what that base state looks like, and it compares it to what you have. So in the library book example, it's a little bit different because it's not looking for something out of place, but rather it's going to help you it's going to help you get closer and closer to the call number of the book where you're looking for it, find that gap. And then once you finally find the gap, you put the book in, you ask for feedback on that photo, and it looks at all these book labels. It says, is the call number in order? And if it is, it says success. If not, like we had in the demo, it'll give you both visual and audio feedback of, oh, check your work, it's not in the right place, move to the left.
Indeed. And in the context of our demonstration, what we had done prior to recording that video was take a video of that space and a few different angles of it, and then feed that to the program so that it could get a feel for what the space was like. And then what the feedback loop was doing was checking for alterations from that initial state, essentially.
Okay, we're gonna wrap up this presentation here. You guys did amazing. So thank you so much for presenting. If you guys would like to stop screen sharing now, team 119, you guys can start screen sharing and getting set up. We're gonna have a 2-minute buffer time. Judges, could you please fill out your judging forms within this time? And then we'll begin in 2 minutes for the next presentation. Judges, are you all ready to move on to the next presentation?
Yes.
Okay, Team 119, are you all ready to present?
Yeah, yeah.
Okay, you may begin whenever, and I'll start the timer as soon as you start.
Okay. So hey, my partner is actually not here. He is on a flight right now, but he has a video later here. So we're the non-ninjas. I'm the Punjana Legata, and we created a kind of simple thermostat prototype. I'm gonna try playing this video for y'all. It's my partner Jay made it. Can you guys
Hi, I'm
can you guys
Jay.
see
I was
that?
unable
Yes.
to make
We
Yeah.
can
this
Okay.
meeting because I have some family emergencies that I have to attend to. I have to catch a flight. But our product, our design was a thermostat. We essentially take the temperature of the surrounding and switch on and switch off a fan according to what the temperature is outside. We have a few components that we have listed in these slides, and I think and I believe that our product can help the environment significantly, is helping the environment currently. However, a lot of people misuse these products. So the thermostat would save a lot of energy, help us prevent health risks, lower utility bills. And I feel like our product is really impactful to society as it prevents a lot of harm to the environment, which is what we care about. Sustainability is extremely important. For our project, Nipul,
So yeah, so as he said, we have these are the parts, and I'll show the demonstration, but we use a breadboard. Let me get that. So we use a breadboard. We use Arduino microcontroller, the LCD display to display the thermal the temperature. Sorry, we have a potentiometer for the LCD display. We have a humidity sensor that just like it senses like the temperature and humidity. We have a DC motor that spins a fan. We have a L29D3 is a motor driver. The motor can't work without it. We have a comparator, the orange LEDs for debugging purposes, a resistor, and we have jump wires to make this all happen. So again, our project is a prototype of a thermostat. You're typically used in in air conditioning systems that we all have. And again, the humidity sensor tells us the temperature of the room we're currently at. We set a threshold. So for our purposes, our humidity sensor is very basic. So it's not as accurate as it could be, so it won't react to like dramatic changes. So we just in our demonstration, which I'm about to show you, we just manually set the threshold to um like just test out the product, but in real time we'd have it set to room temperature that you'd want, and then once it goes over, then the fan starts to run. So as you can see in here, we set it to 20 degrees. And once I push this code, the fan starts running and the LED turns on. And that the LED helps us know like, okay, like the fan's supposed to is working like it's supposed to. And here, excuse me, here I changed the baseline so to 25. So in this case, it displays as 22.9. It's kind of hard to see there, but it's 22.9. So in this case, it shouldn't run, and it didn't run. So that's kind of how it works. Again, if we had more parts, we'd make a little bigger fan, bigger motor, but we don't have access to that, so that's why it's a pencil prototype. And again, social impact. So it enhances indoor comfort, and since it's a prototype, it's a prototype for like it prevents health risks that are usually in ACs. Jay would talk about it, but Jay's from a third world country, and his ACs are filled with I forgot like some like harmful substances, and he thinks that this will prevent health risks. It's also financially cheaper, and it's like very accessible technology wise. And yeah, that's it. Thank you. And if you guys have any questions, I'm here.
This is Anudeep. So how would you like to control the fans, switch or anything else, right? Where do you want to install this component?
Just again, so this is a prototype for models that are in AC, but we also want to just have it like on your own personnel. That way, like if it's hot outside, playing basketball or something, you just clip it on your shirt and boom, you just have a working fan, something like that. But again, this is a prototype. But we would have it in air conditioning, but it does have ulterior like purposes as well.
Okay, cool. Thank you.
So this is Taufik. Could you tell us what part of the project was the most difficult for you to build?
We thought the most difficult part was actually the wiring. So we actually had the coding down because it was pretty simple to code, but the wiring took a lot of time because we actually had to learn a lot of things. Like we have like lessons plans like opened up that we just had to learn everything and just utilize it from there. So yeah, I would definitely say the wiring was the hardest part.
So when you say wiring, the wiring of the display or which part?
So like this whole uh, sorry, like this whole like wiring aspect,
Mhm.
we ran into like a hardship where like this LCD display wouldn't like light up, and I had to ask the TA, and they said like, oh, like there's too much power going into like the motor, so not enough power is going to the LCD display. So we had a resistor, and it fixed all the problems.
Oh, thank you.
Yep.
Hello. So if I understand correctly, right now you just kind of hard coded the temperature set point.
Right. Yeah.
Um,
Temperature
so
sensor.
how in the long term, how do you envision you would have the user interface to control the set point temperature?
Again, so we actually used a humidity sensor from our lab kit, which is not very it's not delicate when it comes to temperature changes. So we would fix that. We just like have a better humidity sensor. And by having
No, I mean I'm asking how does the user control what he wants the temperature to be? Or
oh
is there
so we would have that set. We didn't really have that in our prototype, but yeah, we would have it set to like I guess like the user would have to like change the code, but again, that's because it's a prototype. So
okay? All right, thank you.
yep.
Quick question. Can I ask what is your background? Were any of you electrical engineers or?
No, so my partner and I are both CSE majors. So
Okay.
we're like no, we're not experienced when it comes to other.
Okay,
So
well, that makes sense. Okay, thank you.
sorry, what was that?
Do any more judges have any questions? If not, then um, Team 119, good job. You can go ahead and stop sharing your screen. And then the next team will be Team 124. So we'll have like our 2-minute buffer time again. And then judges, please fill out the judging forms during this time. Thank you.
Uh, Hello, can you see our can you see our slides show here? And can you hear me?
Yep,
We
we
can
can
hear
hear
you.
you. But could you please start in about like a minute? I'll let you know when to start.
Okay, okay. I just a test.
Oh,
Okay.
of course, of course. Great. Okay, judges, are you all ready to move on to the next presentation?
Yes.
Okay, great. Team 124, you can start when you're ready.
I'm sorry, can we
Oh,
just
yeah,
for
yeah.
one more minute?
Oh,
Okay,
1
just for
minute?
1 more minute.
Okay, yeah, sure.
Okay.
So we are running on a bit of a tight schedule, so uh, it would be best if you could start now. I'll probably start the
Okay,
timer now.
I'll start it.
Right?
I'll start it right now. Okay.
Okay.
So hello everyone. The project we were doing yesterday was like a Simon game, and that is we can use that for some psychological research that to help people to identify or to test their memory skill, or help the researchers for their clients to improve their memories. And for the technical difficulty part here, we use some we use the Uno part in our as a MCU for our project, and that's our programming logical parts, and we design some the electronic circuits that, with the buttons and LED, which makes the clients easier to demonstrate the Simon game and test their memory skills. Um, and um, and the input was by the bottoms, and we can see later in the videos that um, when the when the LED turns on, and the clients will choose the buttons to press and see if they can memorize the sequence. Um, and the picture above is the pictures of what we built yesterday. And our project that includes a Uno board, a breadboard, some wires, and some resistors. This is very user friendly because it's very intuitive for each users to use that, because Sim game is very popular and most people know how to do that, and the users can they just need to simply press the buttons, and it do not require any vocabulary or other skills. They just need, so it's very proper for psychological research or some psychological therapies procedures. And some innovative part of our project is that this project is um, they utilize generic hardware components, and it makes that it's easier to re-implement at some scenarios in psychological research, because maybe sometimes the researchers may come up with their ideas and want to very very quickly to test their prototype. They can use our products. It's because it's very easy to build, and and they can use to and we can also provide the code there so they can maybe change some logics to make them more fit to their research. And this project can use for some educational areas, or they can use for some cognitive development research. With that is where we think that is useful for the society or the academic area. Uh, and thank you for listening. And can I show the how our projects work? I will add more. I will add more the um more about the videos we can see.
Okay, we can begin the Q&A session now. So judges,
Okay.
please go ahead with any questions that you have.
Okay. Do you have any questions?
Sorry, I might have missed. Do you have the video of the prototype you have developed?
The video?
I went to the presentation, but is there a working prototype you would like to demonstrate, or is there existing video?
Yes, I can show you the video. And do you want to see the video right now?
Yes, that would be great.
Okay. Can you see the video right now?
Yes. So on the right hand side or the where the LEDs are blinking, basically user has to memorize and repeat that sequence on the left hand side where the user is pressing the different buttons.
Yes.
And
So,
what is the randomness of the LEDs which are blinking? Is there like some logic, or it is a predefined sequence, or it is randomized?
it's a randomized. Every time you run the program, then it will get a randomized sequence of the buttons be pressed. So it is randomized.
And in the presentation, you mentioned that there are some limitations of the existing like similar solution. Would you be able to provide what are those limitations and what problem you are trying to solve? Because what I understood is this is to user has to memorize the sequence and kind of repeat it. So this is based on the research related to memories.
Mhm. Because we talked about some sponsors yesterday, and one of the sponsors he suggested that that is very useful maybe to for some psychological research because there's a terminology in psychology that they call MBAC. That basically is testing the client's memory and they will give them random sequence of some alphabets. And that is pretty much like what we're doing because we are giving them a sequence of LEDs and uh, they can relate it and they can also be used to test their memory in their psychological research.
Okay, thank you.
Okay, do any other judges have any questions?
Yes, one quick question. Is there any feedback to the user that tells them that they did or did not get the sequence correct?
Yes, you can see in this video, because this video is showing a result that if the clients maybe they did the wrong sequence, I can replay that. Sorry. Here.
You don't have to replay it. Just remind me, how did it work?
Uh, there is a button in our prototype, and if the client pressing the wrong sequence, the buzzer will give alerts with the sound, and they know both the
Okay.
clients and the receiver know they did wrong.
Okay, very good. Thank you.
Okay, thank you.
Great. Thank you so much for presenting. Judges, again, please make sure to fill out the judging form now. There'll be a 2-minute buffer time again. And then team 33, you're up next. So if you'd like to start setting up for that, that would be great.
Pardon me, was that team 124?
Yes.
Okay, thank you.
Can you see our screen okay?
Yeah, we can.
Okay, awesome. Thank you.
Okay, judges, are you all ready to move on?
Yes.
Okay, team 33, you may begin when you're ready.
Awesome. Thank you. Okay. We are team 33, and this is SeaMonkey Business. I'm Ryan Jackman.
I'm Ryan Tom.
I'm Mason Young.
And I'm Pranshu Shrivastava.
So let's talk about our purpose. Our project is intended to serve as a comfort to people who have social anxiety or any other social issues. We did some research and we found that 12.1% of all adults suffer from some form of social anxiety. And our SeaMonkey project is meant to be a basic version of someone to interact with their surroundings in an environment that they're comfortable with. We want to have people be able to interact with the sea monkeys without having to really put a strain on their social anxiety.
So the concept behind our project is a rock, paper, scissors game between the user and sea monkeys utilizing computer vision and user input. So our computer vision component uses an iPad camera and code to detect the movement of the sea monkeys to generate their game choices within our entire project. And our Arduino's hardware setup, the purpose of it is to receive user input and display the scores and game choices of both the sea monkeys and the users for each round. This is our video.
Hello, this is a demo for our SeaMonkey Rock, Paper, Scissors project. As you can see here, we're using computer vision to track where the sea monkeys are in the tank, and you can see where they are with the green rectangles. And this tracks what third of the tank is the most popular with the sea monkeys.
When we run this, it'll tell us which third is, and it outputted 0. So that means the sea monkeys actually chose scissors when they give up rock, paper, scissors.
Over here with our electronics display, we have the results of our experiment. In my left hand, I have a joystick that'll track the user's choice depending on which way I move it. Right here, we have an LCD display that will track the user and sea monkey, which choices they made, and it'll display them on the screen. And up here, we have a 4-digit 7-segment display, which tracks the score of the overall game. So for example, if I move this joystick right and I select paper,
As you can see here from the serial monitor, the Y values are going above 1,000, and that's indicating that the user is using paper. So now let's give our code a second to run, and let's go back to the results.
so as you can see, me, the user, selected paper, and the sea monkey selected scissors. Oh shucks, it looks like I lost. I'm down 0-1.
Yeah, so that was just like a demonstration. Oh, that's not what I meant to do. A demonstration of how our prototype works. That also leads us to the biggest challenge we faced, was making everything work fluidly together. Unfortunately, we couldn't have like complete connectivity, so there's a bit of disconnect between the computer vision side for the sea monkeys and the user side. So all of that is hard coded right now, but in the future we hope to implement it so it all works fluidly together.
All right, let's talk about scale and potential. So right now we have the basic version, which is just rock, paper, scissors with our sea monkeys. It's a very basic thing. It just shows us our bare fundamentals. What we want to do in the future is we want to expand it. We want to have the sea monkeys be able to perform more complex tasks because we want it to serve our end goal, which is to sort of have a almost like a service pet type of deal with these sea monkeys, where it's just a comfort for people with social anxiety or any other social issues to fall back on when they need it. But that's only one of our potential end goals.
Yeah, so another potential utility for the randomization model that we use in this project would be complex encryption. Basically, the way that sea monkeys move throughout the tank and where they are in the tank is completely random and cannot be predicted by any human model. As such, we can create a complex encrypted password where each character is determined by where the sea monkeys are in the tank. And through this, we can increase the security for companies around, and we already see some companies doing this. One company is using a lava lamp and its random movement to be able to determine a random seed. So we hope that we can use the randomization model that we use in this project to scale to other companies and help with their security. But yeah, that's basically it for us. We can open the floor to any questions.
Hi, this is Mustafa. Thank you for your presentation. The first question I have is the idea is the person with the social anxiety, they will be able to play this game and to kind of elevate or reduce their social anxiety. Is that understanding right?
Yeah. It's sort of meant to serve as like a comfort for someone with social anxiety. The idea is that you're able to interact with someone without having to really like test yourself or have to step out of your comfort zone. It just is kind of a safe option.
Similar to like pet therapy that's used for a lot of social anxiety.
And how do you measure how much it reduces, or are there any existing products in the market, same or similar, or maybe different idea that playing these kind of games reduces the social anxiety?
So a couple things we thought about is obviously pet therapy, since the sea monkeys are alive, but we also thought about the applications of like a fidget cube, which is something that sometimes people will just play with to just sort of get their mind off of something. And that's where we brought in the interaction with the sea monkeys. So our basic right now is just rock, paper, scissors. It's just something you can do because with like for example, like a service dog, you can't interact with a service dog. Like you can't talk to it, so to speak. So that was our idea with kind of combining those two forms of therapy into one.
Understood, but is there a way to kind of measure that this is working? Like, what would be the mechanism? What it captures that yes, you are able to play. The person with the anxiety will play, but how do you detect whether it is helping with the anxiety or not?
So with this thing, it's more so like a tool that would be used by the users, and mainly the tracking of progress would probably be outsourced towards therapists or specialists, where they can regularly track whether this method of therapy is useful for them. It's very similar to how with pet therapy, there's no finite like number to show whether it's effective or not, but through specialists viewing this as whether it's an effective method or not.
Thank you.
Are there any other questions?
I have some questions about sea monkeys.
Yeah,
Where do you
yeah.
get where do you get sea monkeys? How many sea monkeys were in the tank? And how long do sea monkeys live?
So we got these sea monkeys right here. We just got them from Amazon, but we don't have a definite answer for how many are in the tank. It's like around 10. And for how long they live, we don't have a number for how long each individual sea monkey lives, but they like repopulate the tank just like as time goes on. So there are actually 2 pregnant sea monkeys in this tank right now.
Huh.
So it lasts a very long time because as
Yeah.
long as it's in the right conditions.
The idea is that sea monkeys are a low maintenance animal, so you don't really have to put a lot of effort into actually taking care of them. I think you only have to feed them like once a week. Actually.
Yeah.
So.
All right, thank you.
Yeah. Yep.
Any other questions?
Okay, since there's no more questions, we can wrap it up there. Great presentation, guys. Yeah, so
Thank
if you
you.
guys wanna, yeah, so if you guys wanna stop screen sharing, judges, please make sure to fill out the judging form as well. Team 125 will be next, so you guys can start screen sharing and preparing. And again, there'll be a 2-minute buffer time.
So this will be A.
Okay, judges, are you all ready to move on?
Yes.
Okay, in that case, team 125, you can begin when you're ready.
All right, can you hear me?
Yep.
Awesome. All right, so this is our project Dot Dash, and my name is Gary Zun.
My name is Shaik Chakrabarti.
My name is Ari Pathak.
My name is Louis Lim.
And here we have our Dot Dash project. Have you ever wanted to learn Morse code or know Morse code? Well, with our project, you can use Morse code by, with the press of this button and pressing it multiple times, you can send a Morse code and it will translate it into English letter or number. And every time the button is pushed, the LED lights up and the buzzer buzzes. And here is a demo video of how our project works.
So this will be A. And the next one will be G. And the next one will be Z. And the next one will be 6.
Yep, and that's essentially how our demo video.
So this will be 8.
So the purpose of our project is to translate Morse code into English, letters and numbers. And as you can see on the right side, these are all the conversions from letters and numbers to the dots and dashes. And a long press on the button results in a dash, and a short press results in a dot. And we also have the buzzer and the LED for blind and deaf people to also use this product. And they can tell that they're pushing the button when the LED lights up or the buzzer sounds.
So while building this project, we encountered multiple challenges. For instance, when we were trying to write the code for this project, we had trouble managing the pointers in C++ and adjusting to the Arduino IDE to write this code. And also changing the frequency of the active buzzer so that it changes according to the dot or dash, depending on what the user puts in a button. And in addition, we also had trouble configuring the circuit. So for instance, we had trouble getting all the wires correctly connected to each other with the other components in the circuit, such as the button or the buzzer or the LCD. But as you can see in the demo video, we were able to fix all of those issues.
Future improvement can be, instead of just having letters and numbers, in the future we want to be able to print messages and words. Another improvement we want to make is to make it look more authentic and have a better design. Yeah, thank you.
And that is pretty much our whole project. Thank you. And if you have any questions, let us know.
Hey, this is Nageshwar Rao. Yeah, it seems good, but I would like to know the motto is like a private secure communication, or what is the motto is here?
Like the motto. So in this case, we want to basically make communication better between people who have trouble communicating with others. And I mean, you can say yes, it's like it's helpful for the private communication. I mean, as you know, like Morse code was also used in war, during wartime and all. And yeah.
So I just want, hey, this is Anudeep. I just want to understand one thing. Is it something called voice recognition and then generating the Morse code, or?
No, so what's going on is that, as you can see in the demo video, right? Like the
Yeah.
button in the circuit. So the user will press the button. If they press
Okay.
it for a long time, it will be a dash. And if it's pressed for a short time, it's a dot, basically. But
Okay, so
it's not. Mhm.
the user should know the Morse code before using this.
Yes, that is true. So that is something we also want to improve on in the future, such that it will be speech to text, basically. Basically, like the user will say something and then the machine will basically recognize that as text and then go from there. And then like basically like configure that into the letters.
Okay, thank you.
Question, what if the user enters a wrong sequence of buttons for a code? What does your system do?
Yes, so in the demo video, I don't know if you caught that, maybe it got cut off in the video, but in the very beginning, there was a question mark that came up on the LCD. So if there's two circumstances under which this question mark comes up on the LCD, either the user gives a wrong input in Morse, and that's when the question mark comes up, because the machine is unable to like recognize that as a Morse code character, or the user hasn't put any input in, and that's when the question mark comes up.
And then you mentioned this is for folks with some disabilities. How would they be notified if they can hear or see very well? What is your solution for that to let them know that the code they entered was not valid?
Um, well, yeah, the issue is if it has happened, nothing has been done yet in the machine, but we are trying to improve that later on.
All right, thank you.
All right, thank you so much.
Yeah.
Are there any other questions? Take that as a no. Thank you,
Okay,
guys.
great. So great presentation. You guys can stop sharing. Okay. All the judges, like, please make sure again to fill out the judging form. We'll have the 2-minute buffer time again, and team 11, you guys can start setting up. Judges, are you all ready to move on to the next presentation?
Ready.
Yep.
Great. Then team 11, you guys can begin when you're ready.
Hello, we are the capstone team building a NASA rover. I'm Colin Edders. NASA does the Human Exploration Rover competition as a way to get students involved in designing a man-powered 2-seat rover for the upcoming Artemis missions. Part of the competition is to build a task tool capable of illuminating a control panel, clearing debris from solar panels, retrieving samples from a downed lunar rover, and connecting battery clamps in an attempt to repair the downed lunar rover. Next slide. This was our initial design sketch to get a general layout of how we wanted our tool to look. We incorporated a brush and a light on either side of the handle using the brackets in the second picture. And again, this is just a quick sketch. We also designed a mechanical claw to be activated from the grip end of the tool. Our plan going in was to 3D print these parts and fasten them to some type of tube like PVC. And each member in our group used SolidWorks to design the parts before sending it to be 3D printed.
So like Colin mentioned, we used SolidWorks to design our parts. Starting at the top left, we have a threaded rod end. To actuate the claw, we're using all thread to run the length of a tube. To the right of that, we have our brush mount. We have 2 of those to secure the brush to the tube. On the top right is the flashlight mount. And then in the bottom left corner is the claw assembly. And then next to that is the handle assembly. And then in the bottom right are some examples of it parts after it came off the 3D printer.
And then that picture there is the final product. And I have it here. I'm going to attempt to do a live demonstration. But just to clarify, this is part of a student challenge from NASA. So it's going to be a competition. And the different tasks that this has to accomplish. One of them is picking up about a 2-inch diameter cylinder. So I'm gonna try to. So we don't have the actual cylinder, but I'm just gonna use a can as a demonstration, and then this basically just picks it up pretty easily. So that's one of the tasks. Another one is brushing off solar panels for the competition. Which the brush here works pretty well and doesn't move or anything like that. And then the last, I guess there's 2 more. This also has a flashlight on it, since we are in a permanently dark area on the surface of the moon, hypothetically. You need the flashlight to see the downed rover. And then finally, we need to open up clamps to charge the battery. So obviously the clamps are provided and I don't have that with me. So I'm just going to simulate the strength of the task tool by crushing an empty aluminum can. So this pretty well. The strength, as outlined in the guidelines we were given, is it's about 15 pounds of force, and so this can simulate that pretty well. But yeah, this is our final design, and we can open it up to any questions.
Hi, this is Mustafa. So this particular mechanical tool, is it supposed to be used in the automated fashion and will be operated by the astronauts during the spacewalk, or because like on the left hand side, what I see is someone need to hold, or right, or is it?
Yeah. So a little bit more about the HERC challenge from NASA is that it's a way to get students involved in making a 2-seat man-powered rover, and part of that competition is to be able to do certain tasks as if you were astronauts. So the idea is that 2 astronauts would be using our rover along with this task tool to find and repair a downed lunar rover.
Okay, so the like one clarifying question. So if when astronauts would have been in their spacesuit, right, which is a pretty thick, the handle you guys have designed, right, it doesn't have enough space that within that spacesuit they will be able to pick up and use it, right? Where it looks like if I have to use or not in the normal clothing, perfectly fine. But how they will be able to use in the space environment?
There is 3 inches of travel in the handle, and it is 4 inches long. So we haven't tried it with a spacesuit, and we'd have to get more details to test that. But I believe that it would still be usable.
Yeah, and just to add on to that, this is a prototype, so we did learn a lot, and that's a really good point with the PPE that they're going to be wearing, the spacesuits and all that. We need to take that into account. And the few other things that we found out while making this was the weight of it, just by holding it from the handle, is probably, it's really heavy on the end. So you kind of need a support hand right here, or we need to design a better handle to better support the weight distribution there.
Okay, thank you.
Hello, this is Saida Ziyaifard. So when you were doing your market research or looking at the similar devices out in the market, did you find anything that resemble your device? Which part of this was your team's innovation for the design?
Okay.
Go ahead.
Okay, so I guess on the market, we really didn't find anything that could do all of the tasks outlined in the handbook and the guidelines that we were given. So that's kind of why this was something that we wanted to dive into a little bit deeper. But yeah, I think this, we kind of obviously like certain aspects of it, the flashlight, the brush, we kind of took inspiration from things that we knew on like light source and like brushing off the solar panels, and we kind of used that in this design.
Thank you.
Hey, do you have the opportunity to test this tool by simulating moonlight conditions, just to see how it operates? I know the gravity is probably 1/6 of what it is on Earth, right? As well as it's probably close to near a vacuum there on the moon. So just to see how this works when it's really on the moon. Do you have the opportunity, or NASA, or does anyone provide you the simulating conditions to be able to test your device?
Yeah, unfortunately we don't. And that is be really helpful, because this is just one part of the competition. Obviously, we still need to build an entire rover for 2 people. So that is this competition, while we can't simulate the 1/6 of Earth's gravity, it's more of just simulating the terrain of the moon for the rover part, and then this is just the tasks. But we don't have an opportunity to really simulate how gravity would affect this task tool. We just have to make our best, do a lot of research on that, and figure it out from there.
Great.
Thank you.
Thank you so much for presenting. It was a great presentation. Please stop sharing your screen. Team 43, you may start preparing and getting set up. And then once again, judges, you'll have like this 2-minute buffer time. Please finish the judging form. Thank you. Judges, are you all ready to move on?
Yes.
Yes.
Okay, in that case, Team 43, you can start when you're ready.
Hi, can you hear me?
Yes.
Hi, this is our Make Ohio 2024 project. I'm Zach.
And I'm Will.
And this is our tic-tac-toe. So our goal with this project was to get out of our comfort zone and build something that we haven't built before. This is our first time building a circuit outside of our required classes, and we thought it'd be a good and fun opportunity to take part in this event. It's also a super fun event, so. Our components are listed here. We use 9 LEDs, 2 resistors, 2 push buttons, 1 speaker, and 1 breadboard, and lots of wires, of course. Here's a quick summary. Basically, it functions by using the 9 LEDs set up into a 3x3 grid on the breadboard. X for the tic-tac-toe board. Two buttons will allow each player to change which LED is currently selected, button 1, and then the other button is for the user to confirm that they want to mark the LED at that spot with an X, solid color light, or an O, flashing color light. The game ends when either 9 LEDs are selected, which would be a cat's game, or one of the players gets 3 in a row. And then here is a video of us showing project. So the one that's flashing right there is the one that selects. So that button is to select them. And then that button confirms it. And so now it goes again, that's player 2. And then as you can see, the solar flashing one is the second player, which is the O. And then there you go. And then that's 3 in a row. So the player with the X is player 1, 1. And that was just a quick demonstration. Then so our learning outcomes, some technical skills that we enhance as we gain hands-on experience with Arduino programming and circuit design. We develop proficiency in using digital input and output pins for controlling LEDs and reading button inputs. And we also enhance understanding of game logic implementation in the Arduino software. We also learn, for problem solving, we learn how to troubleshoot and debug hardware and software issues. We also experience in iterating design to improve game functionality and user interaction. Of course, teamwork and collaboration. We improved our ability to work collaboratively on a technical project, dividing tasks effectively and supporting each other's learning. We also developed our communication skills by discussing, specific challenges. And also educational engagement. We created a hands-on learning experience for the user that use electronics and programming for beginners, and then it also engages users by turning a classic game into an interactive educational tool. And then I think that's the last slide. Ready for questions?
Hello, how many buttons did you use for playing the game?
We use 2 different buttons, one to select which of the 9 LEDs you want to enter, and then the other button to confirm it.
So you have to go through all the 9.
Yeah, it does skip if the button or if the LED is already selected as an X or no. So, yeah, if like for say you have 4 already selected, you only cycle through 5 of them.
And can I ask, what are your backgrounds?
Both of us are computer science majors.
Okay, all right, thank you.
Hey, one question. So it's playing between 2 people, or it's playing with some computer kind of?
2 different people.
Okay,
Just in the video demonstration, there's just one person playing both teams.
Okay. I mean, when playing between 2 people, can't we differentiate with 2 different colors of LED bulbs so that we can?
Yeah, we could. It just became a little difficult with all the wire management and pin space.
Okay, cool.
But that was the original thought, to use some of the RGB LEDs.
Okay, cool. Thank you.
Yeah.
Was there some kind of feedback to the players to say you win?
Yes. So on the actual terminal on the computer, once either player wins, it says player 1 win, player 1 won. If the solid colors are like 3 in a row, and it says player 2 won if the flashing ones were 3 in a row.
Okay.
Do any judges have any other questions?
I do. What was the most challenging part of this project? And did you have to change something while you were developing this game?
So I would say the most challenging part would be having the button having the button cycle through the selected LED, especially trying to go over ones that are already or have already been selected. I would say that was difficult. We had to use a lot of like state, and each button had like a 1 or a 0 depending on if it was active or not, and just figuring out how to do that was a bit of a challenge. And something we had to change, we originally wanted to use almost like a joystick to specifically move where you want to like enter the input at, and maybe like click down with the joystick to confirm it. But it just became a little too difficult with trying to map it all to like the 2D space.
Thank you.
Hey guys, good job. I have a question. So how that reset will work? Like LEDs for two players working, right? So if they once the point, as you said, once points or who wins that, it will display. And later, if they want to reset that thing, how that works?
At the moment, we just have, once the game's over, all LEDs are solid and there's no more inputs that are taken. And just to reset, we use the Arduino reset button, and it just starts right up again.
Okay.
Are there any more questions? Okay, if not, then you guys are good. Thank you for presenting. And that was our last presentation. So judges, thank you for your time as well. Yeah, we're good to go.
Thank you.
Thank you.
Yep.
So what are the further steps for judges? Anything?
I believe you just need to solidify your choices and stuff by 2 p.m. And I'm pretty sure that's it, but I will double check, and I can have my other teammates as well, like email further information. But yeah, you
So
all
you
may
want us to
leave
wait?
oh no, you all may leave the call. I'll have them email the further information if there is any. But as far as
Okay.
I know, it's just like solidifying the decisions, the final decisions by 2.
Perfect.
Yeah. Thank you so much again.
Thank you.
Thank you.
Thank you.
Thanks. Team 43, I will get back to you on that if you guys want to stay on the call for like a few more minutes.
Hey, Nitya, so do we need to join in a different breakout room now? No.
No. You're all done. This is like, it was different. There's different judges in each room. So
Okay.
yeah, but thank you so much.
Yeah.
Yeah. Okay, so the videos will be uploaded to a Google Drive folder and they will be shared in the Slack. So you guys will be able to access it after. You guys good? Okay, great. Thank you again for presenting.
Steps are pen.
Oh, no, you should all be good to go to leave. Thank you so much. And also